In our intersection solves or interpenetration, we have a triangular prism going through a triangular tetrahedron is actually the term for that shape, where it is made up of equilateral triangles. And we're starting off here with a 30-degree angle going up by 60 millimeters, then stepping out by 20. There's my pencil now. So step out by 20. That is our tetrahedron. Now out by 75, and then we need an inclination of 20, which means I need my protractor. So we start from this point here at an incline of 20. This is the profile view of the inclined prism. It is 65 millimeters in length. It is an equilateral triangle. So once we get points A and B, we can just use our compass to then set our distance to the 65. Swing an arc to the top from each side, giving me the last point, which will be point C. And then that's the profile of my triangle. Now remember, when this shape is created, this is the back, and we move towards the front. Point A is the back point here that was provided, so I can label that as AA. And I can then also draw in the distances, or measure the distances at this 20-degree angle. C comes down, and B comes down, just to tidy it up slightly. So I can then take those distances. So this here will be D1, and this here is D2. So I can take D1 from A to C, and then we transfer it there. So that's the distance from C, bring that across. And the distance of A to B, it's the exact same thing here. Bring that across there. So that's how I get that. And then I can bring these 3 points back down. So our point C then hits this 30-degree angle. Oh, I brought down the wrong angle. So set up to 20 degrees. Up to C, and it is inclined at 20 degrees. And there's point B, inclined to 20 degrees also. So we have this point here, we'll join back to there. And that is that shape more or less done. So I'm just going to draw it in heavy. So that's a little bit easier to see. And that point then the first part of the question says, in the diagram, a triangular base prism is positioned with its base inclined at 30 degrees to the horizontal plane. Draw the plan and elevation of this pyramid. Okay, so the pyramid is drawn. Then part B is an equilateral triangular prism of 65mm side penetrates this pyramid as shown. Draw the outline, elevation and plan of this triangular prism. Again, there is the outline of the elevation and the outline of the plan, all based off the profile. So now part C is complete the drawing showing all lines of interpenetration. So in order to do that, what we're going to have to do is we're going to have to project an image down here at our angle of 20 degrees. And so therefore I'm going to need sliding set scores for this. and I'll bring all my lines, all my points down at 20 degrees to create an auxiliary view. Okay, so to create this auxiliary view, projecting down our two shapes, we're going to go back 2 views, 1, 2, and get our measurements from our XY line down. So if I give this tetrahedron some points and some numbers, I call that 0. So that will be 0 there. That'll be 1, 2, and 3. So therefore this point is 1 and 2. And this point is 3. So take our distances here for all, and what I actually will do is I'll create, because I have very little space on the page, I might have to attach on, but I'm going to create a measuring line just to make life much easier. So that's going to be my ML, which is my measuring line. So therefore point 1 is going to be 0, which means that that's going to be point 1. So, taking my distances then from ML for A, as follows. A, from ML to C, ML to 3, from ML to B, I might just be lucky enough to fit it on the page. Highly doubted, but we'll see. Then from ML to 0. It's there. The last one, ML to 2. Just unlucky enough to run off the page. Double check that distance one last time and draw it in there. And that is point 2. So that's all my points apart from this. I'm just going to join them up. So O is joined to 1, or 0 is joined to 1. Which means that that's going to go that way. 0 is joined to 2. That way. 2 is joined to 1. 2 2 is joined to 3. 3 is joined to 1. And 0 is joined to 3 also. I haven't done any hidden details or anything just yet, but I can do that afterwards. Then we have our triangular based prism, A to C, C to B, and B to A. Now as our shape comes down here, 0, 3 is going to be visible, and 1, 2 is also going to be visible, and 2, 3, 1 is also going to be visible coming down this way, and so I'm okay with those. But we have 3 different surfaces. I'm going to colour them all in 3 different colours, just so we have an idea of what surface we're hitting. Okay, to try and help explain it. So we have a red surface over here, which consists of 0, 3, 1. We have our green surface, which will be here, which consists of 0, 2, 3. And then coming out the back end over here, this could be our yellow surface, which would be 0, 1, 2. So just highlighting that in yellow so we have an idea. I'll show that edge in yellow there. Okay, this surface here then is obviously our 2, 3, 0. 2, 3, 0 is at the front, so that's our green surface. Again, just doing it very lightly so that I'm not impeding the drawing itself. So that's going to be our green surface. And then we have our blue object is going to be the actual triangular prism coming through to hit the object. Okay, we could have the bottom of the object is pink, but it's not going to be affected. Okay, so we are going to draw this in now. We're going to figure out how to do it. So basically what we will be doing is C to A are on the same surface. Guys, I'd like this video done up and then sent on to ASAP, or you can always find one on YouTube if you want. Is that okay? But I started, I'm going to get this one done. So C to A is on the same surface. It intersects with the red surface, which means it's going to be directly from one point to the other. Okay, so we need to find out where does that stop or hit the sloping surface, the red surface. So what we're going to do is we're just going to join a line from point 1, and I'll do this in green pen, from point 1 through A to the line 3, 0. So we're going to draw that same green line in my other view, or other views. And we go 20-degree line here. 20 degrees. Slide that up to the green location. The green line is going to come back to where it is in this view, which is 0, 3. Find that on point 1. Wherever that crosses the A line, that tells us where it stops. So this green line, we call this 1T. There's 1T. And so wherever this A line comes across and meet it is the stopping point. Now we have to observe that A hits at the back, so it's going to be a hidden detail. So we can draw that in. Hidden until it gets to there. Okay, that's one. We're going to do the exact same thing for C. And so we'll join 0 through C. Green line till it hits another line that we can draw, which is a point on line 3, 1. So I'll bring that up until it hits 3, 1. I'll call that OR, and OR, that up to 0. And then again, wherever C crosses it, gives us a stopping point. So it gives it there. So again, it's going to be at the back on the red surface, which is at the back. So it's going to be hidden detail here. Okay, and then what we can do is, because C and A are on this intersecting or coming into the same surface, we can join them straight up. So again, they can be connected with a dashed line because they're at the back, they're on the red surface, which is back here. Okay, and then as we wrap around, C is going to go to B, however, or sorry, A is going to go to B. A is on the red surface, B is on the green surface, so therefore we have a turning point which we need to find. That turning point we're going to call S. S needs to be found, so we're going to take our 20-degree inclination. We go to the turning point, and we bring that turning point back to its same line, so it's on line 3, 0. So S, we go to where 3, 0 is. That's the location of S on the line 3, 0. So therefore, as I'm going to A, before I can connect it to B, I have to go to the turning point. So this is where A ends or intersects the other object. So I go from A to S at the back of the object, and then it'll go from S to B. And again, we have to find out where B stops. So I will conduct my same work. So I'll just, because this is a green surface, I'll do it in red. I'll draw a red line here. Yep, red line going through there. We have 3, 6, we'll call this point 6. It is on the line 2, 0. And so therefore, if I get my angle of inclination, I bring that, so just double check that I have it set right. My angle of inclination, bring that to point 6. 6 is on the line 2, 0, so I'll bring it back to 2, 0, which is here. So therefore that's point 6. 6 will join to point 3, wherever that crosses the B line will give us, here's my pen, this one, wherever that red line crosses the B line will give us our finished location. So B will run along here and stop there. Therefore that line is going to go solid. And then this line here is also going to go solid because I see the bottom of it. And then once I get to the B stopping point, I'm going to go to C. Again, they're on different surfaces, so we have a turning point here, which we'll call this turning point Q. Come in. Not for me. That's it. Q is on the line 3, 0, so I will get my inclination of 20 degrees. Bring it to Q, bring Q back to the line 3, 0, and identify point Q. That is a turning point, so we're going to go from B to Q. Okay, that's on the line, on the green surface, on the line 3, 0, and then it's going to go from Q to C. which is we've already found here. So it's going to wrap back around to there. That's going to be on the red surface, which is at the back, which is hidden. So it's going to be hidden detail. And so therefore, for my blue object, that's going to be hidden, so that will go to there. That there is essentially what is visible. And that there's what's visible on that. Okay. So, haven't found these in plan yet, but I'll bring them down in a few moments. So just going to figure out the front elevation first, and then we can bring them down to plan. So, I've done, as the triangular prism enters the pyramid, we've done that. So in front elevation, so let's just find them in plan. So I'll bring all these points down. So we'll bring B down. We'll bring this point down here as well. We'll bring Q down. Bring A down. We'll bring S down. So wherever this connects with C, C is on the top of it, so that's going to connect and stop there. So therefore that's going to be a solid line. Okay, A finishes here, which means that there is going to be a solid line. A connects directly to C. That, it's A and C. Then A goes to S, so S is here. S is on the line 3, 0, which is on the underneath, which is here. So A will go to there, in a dashed manner. So that's S. S goes to B, which is here. Again, that's underneath. So from the top I won't be able to see that. So that's B. Across to there. B goes to Q. Q is on the line 3, 0, which is here. That will be visible. And then Q goes to C, which again will be visible. Okay, that's our blue surface, or our blue triangular prism. Okay, and then we have to figure out how it exits the object. Okay, and this here is an edge view of the yellow surface, so therefore wherever they exit here, we just have to transfer them down there. So this is an edge view, so these are true. It's a true representation of the exit points. So if we bring down A to A, we bring down B to B, we'll bring down C to C. That will give us our exit points. So C will finish there, which means it exits here. A exits there, which means it exits here. And B, it's this line here, which exits there, which means it exits there. So therefore, go like that. dashed line. Like that with a dashed line. Like that. With a dashed line, and then we're going to connect them up. So A goes to B. Again, it's going to be hidden by the top surface. A goes to C. And C will go to A again. And just for clarification, this actually surface is red. So that was on the page. This surface here is red. Here's our red surface. This surface is our green surface. Excuse the colouring job. And then we have our blue object exiting again. Like so, and then blue object here. Exiting. So I'm just going to do these in heavy pen so that we can see and highlight exactly what's happening. It's not just quite finished, I have to join this up here. And that's that done. That's that question complete. 2012 Interpenetration.